is the protection role of cysteine for copper, 5 zinc, 5 aluminum, 1 tin alloy corrosion in 3.5 weight 5% sodium chloride solution. There is to work here. The corrosion of this is a golden alloy. Actually, it is a newly produced alloy, and its protection, the inhibitor called cysteine. I will go through this outlines, introduction, and the others are the work, the experimental work. The first two are electrochemical tests. The first one is potential dynamic polarization test and electrochemical impedance spectroscopic test. And the other one is X-ray photoelectron spectroscopic test and the discussion and summary. As an introduction, copper and its alloys have a wide range of applications in the world. They can act as for architectural, for electricity, automobile, for oil refining as a tube and a pipe for water and other household equipments like this. So it is a need to protect this material. It's important to protect this material. Actually, in the world, there is really high economy that is often to protect the materials or materials reuse or like that. So this copper and copper alloys can be corroded in different situations in the sea and the electronics, in the pipes and other usage in the power station like that. So it is a need to protect. One means to protect this material is corrosion, using corrosion inhibitor. It is not the only means. It's not the only means that it's one of the means to protect this material. Corrosion inhibitors are a substance. When they are added to the environment, they can reduce the corrosion rates when exposed to the corrosive environment. These corrosion inhibitors can be classified based on their nature and also based on their inhibitive effect. Based on their nature, they can be classified as organic inhibitor and inorganic inhibitors. Recently, the researchers are focused on organic inhibitors because this time it is a need to search for a green environment. So these organic inhibitors are non-toxic. Actually, some of them are expensive, but some of them are cheaper. And inorganics are a little bit toxic. So I choose the environmentally friendly inhibitor, that is cysteine. Cysteine is just a kind of organic inhibitor. It is an amino acid. The other classification of corrosion inhibitors are based on their inhibitive action. They may be anodic, cathodic, and mixed type. In the corrosion mechanism, the process is electrochemical process. So if we add an inhibitor to the solution, if they retard the anodic reaction to protect the metal, it's called anodic inhibitor. If it retards the cathodic reaction or the cathodic mechanism, we can call them cathodic inhibitors. And if they retard both anodic and cathodic part, it is a mixed type. Actually, this type is a good type because they can protect the metal or the other material in a better way. This is the potential dynamic polarization result. We can describe this result or this graph. This based on the current. Increasing the current shows the inhibition. The material is damaged. This means in the continuous contact with the corrosive environment. So if in the presence of inhibitor, if it is the current density is lowered, it means this material is act as a corrosion inhibitor. You see here, we can calculate the corrosion, sorry, here. Yeah, we can calculate the inhibition efficiency. This is based on the current density here. The concentration of 10 to the power of minus 2 molar of cysteine can have 97.2%. So the inhibition efficiency of the cysteine for the golden alloy, this copper alloy, is depend on the concentration of the metal. Beyond this concentration, it becomes decreased because there is recombination. The surface field becomes recombined, so it may damage. This is also the EIS, or electrochemical impedance spectroscopy result. This is the nucleus in the left and the board one in the right. So you see here the blank solution. Here there is a straight line in the low frequency region. This shows the presence of Wohlwerd. This Wohlwerd is raised from the presence of diffusion between the metal surface to the solution, the bulk solution, or the solution from the metal. The solution that is oxygen, the dissolved oxygen, so goes to the metal, it may damage. So in the blank solution, there is the reaction is controlled by diffusion. But in the inhibited surface, there is also diffusion, but it is the reaction is not controlled by the diffusion. The diffusion is minimized in the presence of cysteine. You see here there is no Wohlwerd. Also the diffusion reaction is minimized, and also here the increment of the this semi-circle indicates the inhibition, the increasing of the inhibition efficiency of this inhibitor. And also we can calculate the inhibition efficiency using resistance. This resistance of film, the resistance of solution resistance, and also charge transfer resistance, and there is RP, the polarization resistance. We can calculate the inhibition efficiency here. These parameters can be obtained from the simulated circuit. We simulate this graph with the circuit by using a software, so we can gain these parameters and we can obtain this inhibition efficiency by calculation. So we can get 96.4 for of inhibition efficiency in the presence of 10 to the power of minus 2 molar of cysteine. This is the XPS result. This is for copper 2T and copper LMM. That is the Auger. There is Auger also conventional XPS. I did this audio. This is because of it is a little bit difficult to differentiate the peaks between copper 1 and copper 0 in the XPS, conventional XPS. But in the audio spectra, we can differentiate them clearly. So here we have three types of three species of copper: 0, that is metal copper, and copper 1 and copper 2. This copper 2 is specially characterized by the presence of satellite peak here, and also here around here, 932 point something is for the characters assigned to copper 2, and here are assigned to copper, whether copper 1 or copper 0. It's difficult to differentiate. They overlap, but here we can differentiate. Here in the blank solution, you see here there is copper and copper 2 and copper 1. The copper amount is too much. This means there is corrosion products around the surface, so the surface is corroded, right? And in the presence of cysteine, the surface is the copper 0, the metallic copper is almost eliminated. This means the surface is covered by the film. We can't get the uncovered surface here, and we can get ionic copper. This means the copper and merged with or can make a complex with cysteine molecules to form copper cysteine thin film. So it can protect the surface. This is for the zinc and tin spectra. You see here is a really beautiful result here in the zinc. You see in the blank solution, there is zinc. And also in the minimum of a small amount of cysteine, also there is zinc. But in the high concentration of cysteine, there is no zinc. This means that the alloy is bounded by copper cysteine film. In the upper surface, there is copper and cysteine. It's bounded. Other alloys are bounded. Other constituent metals are bounded by copper alloy, because we have seen that there is copper in every species, in every sample. Also, the same thing in the tin, in the presence of high concentration of cysteine, the presence of tin is very negligible, like zinc, but there is a small amount of tin. This means that tin can be participated in the tin formation. There is tin cysteine film also. This is copper and sulfur and nitrogen spectrum. This spectrum shows that the presence of inhibitor film, because the cysteine contains nitrogen species, it has sulfur species, it has oxygen species, and copper species. So in the blank solution, there is no sulfur. This means there is no zinc, no cysteine, no inhibitor. But in the presence of cysteine, there is sulfur. This means at the top, there is inhibitor, because the inhibitor contains sulfur species, and also the nitrogen part. And the amount of sulfur and nitrogen increased with increasing inhibitor concentration. This means the inhibition efficiency of cysteine can increase with the concentration. This is some illustration for inhibition mechanism. You see in the blank solution, there are ions, and maybe these ions can form oxide. This because there is dissolved oxygen, as we can see in the EIS result. There is diffusion, right? So there is ion diffusion, ion from the surface to the solution, and also from the solution to the surface, the oxides. So there is metal oxide. But in the presence of highest concentration of cysteine here, there is cysteine copper field. So we have seen in the XPS result. As a conclusion, as a summary here, copper, 5 zinc, 5 aluminum, 1 tin, that is golden alloy, can be corroded by this chloride solution, and the surface is covered by metal oxides. The content of alloy constituents other than copper are decreased in the presence of cysteine and became negligible at cysteine concentration of -2 molar. Potential dynamic polarized studies showed that cysteine is a mixed type inhibitor. The inhibition efficiency increases with increasing concentration of cysteine. The inhibition mechanism relied on the formation of a bounding copper cysteine field on the alloy surface. Thank you so much for your attention. If you have any questions, very welcome.